humble ourselves and we pray. Almighty Father in heaven, we thank you for the gift of today. Thank you for the gift of life. Thank you, Lord, that you are awake and you have come for this lesson. Dear Father, I ask you to come and be with us. May you please help us with understanding. May your will be done in our lives, O God. May you bless our teacher this morning, O Father. We pray that you may give us understanding from above, and may we listen attentively to whatever they're going to teach. And above all, Lord, may your will be done. In Jesus' name I've prayed and believed. Amen.
Thank you so much for the word of prayer. It is exactly 5 a.m. You're going to allow me to disable some features such that we do not have any noise in the background. But let me hope we shall use the chat for anything. Yes, okay. So we are going to start and then the rest will be finding us on the way. So our topic today, we are going to be dealing with circle properties. This topic is a topic that you are meant to do in Senior 3, but we understand that not all schools are able to complete the syllabus on time. So that's why we thought about it, that we can complete this topic in the morning hours, then during the day, we can continue with the other parts. So we are going to look at circle properties. So in your book, you can write your topic as circle properties, and it is under the theme of geometry and measures. So that is your topic. So you write topic, circle properties. Okay, let me hope you have finished. And for this particular topic, our competence is what you must be able to do at the end of the topic. So at the end of this topic, you must be able to use circle properties to solve problems. So we shall look at how we can use these properties to solve problems in the different fields. That is going to be our competence, that by the end of this topic, you must be able to solve problems related to circles. So that is our competence. You can still write it somewhere such that at the end of this topic, you can go back and have a self-check whether you are able to use the different circle properties to solve problems. And then for this particular lesson, our focus is going to be our focus for this particular lesson is going to be on being able to identify what an arc is, what a chord is, a sector, and then the segment. So we are going to look at the different parts that make up the circle, and then we shall dive deep into that circle theorems. So this is our learning outcome. Now, when you look at my screen, the first part we are going to look at is going to be circle and its parts. So let me ask you through the chat to type in the different parts you know about the circle. You can type in anything you know about the circle. The different parts, the circle and its parts. Which parts do you know about a circle? You have been seeing circles around, but which parts do you know that make up that circle? So you can type in the chat, but in case you wish, you can raise up the hand and maybe you can share with us. Okay, through the chat, Patricia is telling us about the chord, favor, diameter and radius, Victoria radius, joy and arc. Okay, yes, so all those parts that have been mentioned are parts of the circle, favor circumference. Okay, Yes, so all those parts are parts of the circle. So we are going to look at those different parts you have mentioned in the chart, and then we shall dive deep into them. So we are going to continue. Now, when you look at my screen, you can tell the different ways through which circles manifest themselves in our daily life. When you look at my screen, you can easily tell that some of these things are common to you at home or in the things you interact with in daily life. You can check that many of you, when you are riding a bicycle, you can notice that there is an element of a circle. When you look at the CDs, you can notice that there is some element of a circle. When you look at the fan, you look at the coins, you look at the designs of the roundabouts, you look at rings, you look at our national flag. So circles can manifest themselves in different ways in our daily lives. But you can raise up the hand. I have mentioned just a few, but I know in sports, you may find in other fields, we have other fields where these circles can manifest themselves. You can raise up the hand and you share with us which other fields have you found the circles manifesting themselves. Other areas where you have seen those circle elements being shown or being used. Feel free to raise up your hand or you can use the chat. We have other that we have really looked at where the circles have manifested themselves. Okay, it seems people have not. Okay, maybe I can share. So when we go into sports, I think those ones, what you're seeing on my screen is something very common in the design of the pitch for soccer, basketball, and other fields. You'll see them using that element of a circle. Those who are in the villages, you have seen young men and young ladies using the cut tires to do some kind of sports. When you look at basketball, you'll notice that the rings are also in form of a circle or are in a circular format. When we come to the food industry, you have noticed that even the baking, you'll find that things are a bit circular. You'll find that in the making of donuts, in the making of chapatis, I think also cakes, you'll find that there is an element of those circular elements. So those ones are depicting what a circle is. When you come to the music, you have noticed that some of the music instruments that they use, take an example of the drums, the shakers, the drum kit, the brass band, you'll find that there's an element of a circular thing. So circles can manifest themselves in different shapes and we can use them in our daily lives. So now we are going to start. What is a circle? Now, when we talk about what a circle is called a two-dimension figure whereby all the sets or all the points from it are at equal distance from the center. When we talk about the word equidistant means that the distance from the center, this is the center of the circle. So any line you draw from the center to the circle must be at equal distance. Take an example. If this is 3 centimeters, any line you are going to draw from this center to meet at the circle, that distance must be the same. So this one should also be 3 centimeters. When I draw a line from here up to here, this one must be 3 centimeters. That is what we call a circle. Should you measure and you find that when you draw a line, let me say this is my shape and this is my center. When I measure from here up to here, I can see that maybe it is 3 centimeters. But when I'm measuring from the center up this point, you will notice that this distance is a small distance compared to this. So this one maybe is around 2 centimeters. So this one doesn't qualify to be called a circle because the distance from the center to any point on the circumference is different. So for anything to be called as a circle, it must have the same distance from the center to all the points that are touching its circumference. And that one scientifically is what you call equal distance, or what you call equidistant. So equidistant literally means that the distance from the center or from the point to all other points on the circumference are at equal distance. An example, I've used the steering wheel. When you look at this wheel of ours, the distance from the center up to where it is touching the circumference, it is the same distance. This distance here is all is the same, and the distance from here up to here is the same. So you can call it that this one is a circle. So always, for you to determine whether something is a circle, always look at the distance from the center to the circumference. The moment you find that that distance is the same, then it means that that one is a circle. Are we together? Are we good to move on? You can let me know in the chat whether we yes or no. Are we on the same page? Okay. Yes, we are on the same page. Okay. Now, the different parts of the circle. Now, when you look at our circle, the first part is what you call the radius, is the part. And when we talk about the radius, who can define for us what a radius is? You can raise up your hand, no problem. What you think a radius is? Okay. Yes, Ian, you can unmute. Ian, unmute.
I think a radius is the distance half of the diameter.
Okay, good. Yes, he has told us that radius is the distance that is half the diameter. Very good. Yes, Patricia?
I think the radius is like the line that joins the center to the circumference.
Okay, good. The line that joins the center to the circumference. Okay, very good. So what you are seeing in red is what you call the circumference. And that thing that we are seeing in red is what you call the circumference. So circumference means that the distance around the circle. And then this middle part is what we call the center. So like what Patricia has told us, that the distance from the center to the circumference is what you call the radius. Or you can say is half the distance of the diameter. So that is the first part of a circle, what we call the radius. So you can summarize it. That's what we call that, the line segment. So the radius is a line that joins any point on the circle to its center. So you can summarize it. When you finish, you let me know in the chat. Okay, Favor also, that is very correct. Distance from the center to the circumference. Joyce, hope we're on the same page.
Yes, teacher.
Favor has told me he has finished. Okay. So when we get about 5 people, we shall then continue. Okay, Paula has finished, Calvin has finished, Victoria has finished. Okay, okay. I think people have finished. And here, please do not mind, summarize your work in a simple way that you understand at a later time. Okay, I think we are good to continue. Then the other part we can look at on the circle is going to be that part. So that is the second part. That let more people have seen it very well. I'm drawing the second part, and that second part is going to be running. The second part is running from point A to point B. Yes, what you are seeing in purple, and that one is what you call the diameter. And when they talk about a diameter means a line segment that joins the 2 points of the circle, but it must pass through the center. So any line that you draw, when it is passing through the center is what you call the diameter, but when it is joining 2 points. So that means that it can be of in any form. So as long as it passes through the center, it can be like this. That one can be diameter. It can be like this. As long as it can be like this, it can be like this. So as long as that line, once you draw it, is passing through the center, is what we call the diameter. So you can summarize it also. When you finish, you let me know in the chat that yes, we can continue. Okay, I think people have finished. Can continue to another part on the circle. So when you look at my circle, I have 2 points that I've labeled. I've labeled point A and then point B. Those are my parts. And I've drawn that line. Let me see through the chart. Who can tell us what is AB? How do we call that line AB? Anyone who knows the name for that line? AB? Okay, Kayong Ian is saying it's called a chord. Patricia is saying a chord. Yes. Okay, so that line is what we call our chord. Yes, Joyce. So that is a chord. So when we talk about a chord, yes, okay. Good. Victor, Paul, Joy, yes, your answers are correct. So when we talk about a chord is that line segment that joins any 2 points on the circle. So whenever you have a circle, any line you draw, but as long as it's joining 2 points, we call it a chord. Even if it is just from here up to here. Even if it is just something that comes like this, those ones are called a chord. Even if the diameter is a special chord. So when you talk about a diameter, because when you look at the diameter, you can notice that a diameter can join from this point to this point. So it is also a chord as long as it joins any 2 points on a circle. We call it a chord. So diameter is a special chord. So you can have as many chords as possible. And when they ask you what is the longest chord, the longest chord is always the diameter. Okay, we can still summarize. Okay, Patricia has finished. Okay, Favor. Luana, are we on the same page? Okay, Calvin, Par. Okay, I think okay, I think we are good to continue. Then we have, I have 2 points there. Yes, and I think you have seen what I've drawn. I have put 2 points on my circle, point K and L. Those are my 2 points. And I am drawing some line up here. Those who can't see it well, I think I can make it better for you. I have joined point K to point L like this. So how do we call that part on a circle? How do we call that part on a circle? From point K to point L. Which special name do you think we give? Okay, very good. Daniela said an arc. Victor, okay. Yes, that is what we call an arc. Yes, so an arc is that curved part on a circle. That one there. So that one is what we call an arc. So an arc is the distance between any 2 points on the circumference of a circle. Then it is from here that now I'm going. So it is from here that now I'm going to talk about 2 things that are going to be important. When we are talking about a circle, we have 2 different types of arcs. We have what we call a minor and what we call a major. So when I'm talking about a minor arc, whenever you draw your circle, the smallest distance, the one that is very small, is what we call the minor arc. Now for this particular circle of ours, the distance from K to L, this one here up, is what we shall call the minor arc. Then this red one, the one you are not seeing, let me even use red for that one. This one here from K going like this, like this, like this is what we call the major arc. Now, these terms I'm talking about, they are going to be very important when we start now the circle theorems. Yes, we shall be talking about minor arc, we shall be talking about the major arc. So always you look at the distance that maybe from here up to here is very small. So the smaller one is what you call the minor. The bigger one is what you call the major arc. So for any circle where you have an arc, you can have 2 types. You can have the minor one and you can have what you call the major arc. So you can write small about the arc. When you finish, you let me know and we continue. Carol has finished. Okay, I think people have finished. Okay, we are going to continue. Okay, so I've talked about what we call the minor and what we call the major. So what we are seeing in yellow is what we call our major arc. Then what you see in, I think, that color is what we call our minor arc. So the arc will always divide the circle into two parts. The smaller one we call the minor. The bigger one or the larger one is what we call the major arc. So in real life, it can manifest itself like that. So some of you who have crossed bridges, you have gone somewhere, you might have noticed something of that nature. So those ones are arcs. In Uganda, I know we can find it somewhere. Yes, I have seen some bridges that have been constructed in that form. So they are applying the circle theorems. So that is what we call now the arc. Okay. I think also that one must be a bit familiar to you. I don't know whether you are seeing it. That one is a bit similar to, we call it the rainbow. Also, it manifests itself in form of an arc. So arcs can be seen in real life through one of those parts. Then I have some few questions here that I want you to read through. Whether any of you has ever split a pizza, and I want you to put in the chat what could be your response. Have you ever split a pizza, a pie, or a cake to share with someone? How do you call the shared part? What about the part that remains? So you can use the chat, or you can raise up your hand and then you let us know, or you share with us. So Victor is saying yes, Ian is saying yeah. Okay, Victor is telling us it's called a sector. I don't know that, Victor, you can share with us. Victor, is it possible to unmute? Yes, so I know everyone has shared. And I think those who have shared, many times we cut them that way. In case it is a cake, you'll find yourself that this is how you are going to cut it, this is how you are going to cut it, this is how you are going to cut it. So when you look at these different ways on how we get a piece of a cake, let me say they have given you a piece, they will give you something like this. This is for pizza. For cake, they will cut and they will give you that piece. In case it is this, it's this. So this part here that they give you has a special name. I don't know whether now people can tell us what name we give that part that people give you. What could be the name for that part, that slice that people will pick and give you to eat? Okay, Daniel said it's called a sector. Okay, Victor also said it's called a sector. So mathematically, that slice that they give you when they cut it in that sambusa form is what you call a sector. So whenever you meet it, it's not called a slice like many of you call them. It's called a sector. And now we are going to go deep and now even distinguish it. We have what we call the minor sector and what we call the major sector. So this one piece that they have given you, this one piece here, is what we call the minor sector. It is the smaller part. Then what remains, now this big, like when you look at our pizza, this part that has remained is what we shall be calling the major sector. So still in the circle theorems, we are going to be meeting those words. We shall be talking about a minor sector and what we call a major sector. So for you can be able to relate that that small piece they give me is what we call a minor sector. What remains after they have cut out my piece is what we shall be calling the major sector. So that is really very important. And maybe, yes, so that is very important, and you can relate when it comes to a sector. What are you noticing? You're noticing that when they are cutting the piece, always they start from the center towards the circumference. So when you look at a sector is formed by two radii. You have a radius from here from O to A and a radius from O to B. So whenever you have two radii, it means that those two radii are going to be forming what you call a sector. Hope we're on the same page. Is that fine? Are we on the same page about what you call a sector? Can let me know in the chat whether we're on the same page. Okay. Yes, now for this one, I want you to just draw it in your book. You can use your free hand, you draw and show what a sector is. You can even write some few words of yours in your own words, what you have understood by a sector. But what is very important, you need to know that a sector is formed by two radii. Whenever you have a radius and another radius, then it means that that part that has been formed by the two radii is what you call a sector. So you draw it and then you indicate it somewhere. But this one is called a sector. Okay, I think people have finished. Okay, then we have other parts. The other one is what you call a segment. For this one, I've already showed you. Now, a segment, we say that line AB is what you call a chord. We have already said so. Now, whenever you have a chord is going to form a part. Now, one of the parts is going to form is this part that I've shaded here down. Now, this part I've shaded here, we call it a segment. This is what we call a segment. But like I've said, when it comes to these parts, you are noticing that you have this smaller one and also you have this bigger one. So the smaller one is what we call the minor segment. Then this bigger one that is remaining is what we call the major segment. Those who play basketball, you might have noticed that in basketball, when you look at the field at the court of basketball, you'll notice that you have what called segments. Mainly here, I don't know how this part is called in basketball, the special name, but I know it's the segment. So this part here around the scoring area. So you'll find that we have a minor segment and we have what called a major segment. So a segment is formed by a chord, whereas a sector is formed by the radius. So even here, I can draw another one, even if it is like this. Remember, we said that also a diameter is a chord. So also this one is what we call, this one is also called a segment. But now these ones will have some special name because it is passing through the center. We can call it the semicircle. Yes, so when it is passing through the center, it has a special name. We can call it the same circle. But for this particular one, we shall have the minor segment and we have the major segment. Yes, you let me know whether we're on the same page. Are we on the same page, members? Okay, Paula said we're on the same page. And Patricia, hope the rest we're on the same page. Okay, Daniela said yeah. Okay. I think okay. I think we can now continue. Okay. Now, what I've showed you, those are the major parts when it comes to a circle. So when it comes to a circle, we shall have the major parts. One of it will be called an arc. So an arc for this particular circle, this is just now the summary, is this one here. And we have said this is like the minor arc from A to B, and the other side will be called the major arc. Then O to A to B, when you look at our circle, this part here, O, A, and then up to B here is what we call our sector. Then the line A to B is what we call the chord. And when you look at this part here that has been cut off by the chord, this one here is what we shall be calling our segment. So those are the major parts. And these are the parts we are going to be talking about when it comes to circle theorems. We are going to be looking at arc. We are going to be mentioning a sector. We are going to be mentioning a chord. We are going to be looking at the segment. So if you have not understood them, then it may be hard for you when we dive into the circle theorems. But the major parts, you need to know what an arc is, what you call a sector, what we call a chord, and what we call a segment. So those are the major parts. But also from your knowledge, you need to know what we call a circumference. That a circumference is just the distance around the circle, and maybe what a radius is, that this distance here is what we call the radius, and the middle part is what we call the center of the circle. So those are the major parts that are going to be relevant in circle theorems. So, and that's those who came in a bit late, and that is our simple summary, what we call a radius, what we call the diameter, and what we call our chord. So briefly, those are the major parts. But some of you may be asking ourselves, but why are we studying this knowledge? Where are we going to apply? So circles are going to be very relevant in the different fields. Take an example in engineering. Whenever they are designing, they are making those structural designs in engineering. They have to use the circles. When it comes to architecture, when it comes to art, the food industry, automotive, aerospace, astronomy, sports, manufacturing, and other fields, you'll find that element of circles being used. So it has quite a number of applications in the fields. So at the basic level, you may not be able to visualize its application, but whenever you advance, you'll find them being utilized, and that's where you'll find them being utilized. So these are some of the fields where you'll find that this knowledge will help you to build on in order for you to be able to advance. So that is briefly about the introduction of this. So I'll expect that everyone now has understood, and allow me to stop this recording.